I'm super excited to introduce our next talk, State of the Shell.
Hello. Whoa. Hello, GUADEC. How are you doing? Hope you're doing all right. Welcome to the nth edition of State of the Shell. As Jonathan once said, this is an acquired taste, and I hope you have a delightful meal of information today. Hope you're all ready. This is me and Florian here. We have some folks in the Berlin side of GUADEC too. In the Berlin side, we have Carlos Garnacho and Robert Mutter. So a honorable mention that is not here, unfortunately, but helped us a lot through making this presentation is Jonas Adl. Yeah, Jonas is not here, but spiritually he's everywhere here, permeating this presentation all around. Welcome. Let's begin, as always, with Mutter stuff. This is a highly technical presentation, so I apologize for just jumping straight into the hardcore coding stuff, but let's try and do it. Mutter has a website. Jakob has been doing fancy little websites for all GNOME projects, and we were the latest victims of the websitization. We have a nice pixel art. There is supposed to be a cat there, but I don't think you can see in the in the projector. But yeah, mutter.gnome.org, you can go check it out, and we have documentation pages for the APIs that Mutter exposes. Usually that's useful for shell extension developers. Clutter, Mutter, Coggle, and everything in between. So yeah, go check it out, mutter.gnome.org. That's mutter.gnome.org. Yeah, one particular feature that it's going to be nice to mention here, it was thanks to our great friend Bilal, we are able to make pure Wayland builds now. You can build GNOME Shell and Mutter. In this case, we're talking about Mutter, but you can build Mutter without linking to X11. I think directly and indirectly, correct me if I'm wrong, but I think it doesn't pull in any X11 dependency anymore these days. The goal here is to be able to produce legacy-free builds, as Bilal put it. Yeah, it required lots of refactorings. It required untangling a lot of old craft. Mutter was born out of Metacity, which is an X11 window manager and a compositor. So X11 is ever present in this code base, and we are slowly ripping it apart. And well, Bilal has been mostly ripping it apart and getting rid of the dependencies in there. So now we reached the point where we can build without it. It is opt out at this point, I think. The next cool thing that I want to mention is explicit sync, which is something that people have been talking about for a long while. This particular feature is heavily associated with NVIDIA. Although it is it has its own merits outside of just making NVIDIA work. It's an interesting way to make composition and sharing GPU load between processes. So essentially, you have, instead of creating a frame and sending it, you add little timeline points, and you send these timeline points to other processes. In this case, usually it's the compositor. So the protocol name is, I think it's sync timeline object, sync object timeline, or something like that. So again, even though it is heavily associated with NVIDIA, because this is required to make GNOME Shell and the compositor and everything work flicker-free on NVIDIA, it is going to benefit other parts of the stack. It is pretty interesting on its own merits. And to me personally, I think what makes it super exciting is that it's going to help with a Vulkan transition, which is not something that we have on the table, but Vulkan, the API, exposes this in one way or another. So it is good for the compositor to have support for that so that we can support Vulkan on the app side, and then maybe we can start thinking about supporting Vulkan on GNOME side. But to be clear, there's currently no realistic plans to make that happen right now. It's a lot of work. This code was, I think it was mostly written by somebody from NVIDIA, actually. Ashton, I think, maybe. I'm sorry, I should have remembered that, but I don't. But thanks to the person who wrote this. The patches were accepted, and they are going to be ready for GNOME 46. They are ready for GNOME 46, so they are now ready on the release. What people have been working on right now is to make screencasting use explicit sync. So just like applications send a sync timeline point for the compositor can send a sync timeline point for applications when it shares a screencasting buffer with applications. And that way you have both applications giving buffers to the compositor and compositor giving buffers to application flicker-free on NVIDIA and fancy on every other driver. So yeah, we have that. For the next one, we have DR-Emlys. This has been long in the making. There have been talks about some sort of service for the session to handle these devices. But in the end, we had a Wayland protocol available, and we just landed. I think most of the work, originally the work was implemented by Jonas Adel, and then it was picked up by 4 or 5 different people over the years. But eventually the final iteration was merged from Jose Esposito, I think. So yeah, thanks for pushing that to the finish line, Jose. Yeah, we have that. So that means one particular part of the VR story is complete now. I don't think, as far as I understand it, is not completely complete. So this is the compositor side of the story. It is working, but we don't have a full story, a full picture for example, sandboxed VR SDKs, for example. So that's still pending. Nothing to do with Mutter, of course. The Mutter side is figured out at this point. Yeah, so we have that. For the next one is something that I've been particularly working over the past 4 years, and without much success until last month. Snapshotting. So this is something that when Clutter was originally merged into the Mutter code base, if you don't know, we have Clutter and Coggle inside Mutter. They are forks of the original projects. The original projects are archived, and our fork still lives on inside Mutter. And when it was brought into the code base, it already had some initial work from Emanuele Bassi on paint nodes and deferred rendering, but it was super far-fetched. Like, it required still a lot of work to complete the story. And over the years, there have been like flickery progress on this, on and off. But finally, like, after GTK folks presented us with a fantastic API for snapshotting, I think it was pretty clear that we should definitely be heavily inspired in that. And I'm saying this, just not say that we just copied that and changed the function names. But it was pretty good, and now we're adding something spiritually similar to Mutter. What is deferred rendering, you may ask? And I had to look it up. It was exactly 4 years ago that I wrote this slide. This is a paint node tree. This is just an example, tiny little example. So essentially, you have rendering operations like paint a color at a particular rectangle, or change the transform matrix to something else, or maybe clip the contents to this particular rectangle or this particular box, or paint this particular image in this particular rectangle. All those things are paint operations, and in Clutter, they're modeled as a tree of operations. So that, for example, here we have a clip tree. This one over here. everything that happens inside the clip, every child of the clip node is going to operate under that particular clip, so they're not going to draw outside of that particular area that is being clipped to. This is, I think, slightly different from the GTK approach, which is just a list of operations with a linear list of things. We have a tree of things. But yeah, essentially, snapshotting is an object that allows us to build this tree without having to create each node individually and think about them individually. And as of 3 weeks ago, I think I managed to get the first build of GNOME Shell that was able to output a complete paint node tree from everything, drawing the wallpapers, the top bar, the windows, the textures of the windows, subsurfaces, and everything, effects, all that you can think of, all in a massive tree of paint operations. It was super slow, it's terrible. I don't think anybody should use this at this point, but it works. Yeah, that's something I've been working on. And it's still an experiment. I don't have a timeline for when this is going to happen. But to me, it's super exciting because this is going to make a little bit easier to implement things like plane offloading. So you can take like a window and put it in an overlay plane. And that usually helps with low power devices. You save some energy if you don't have to composite the full window, the full screen over and over. Just take a window and put it on a plane, take a window, put it on a plane, every frame. It's just so much easier to skip the whole thing. It also allows some post-processing of the node tree, so you can have some slightly optimizations, reduce overdrawing, and all this fancy, graphics stuff that are hard to get through. And I think that's going to be it for me, because the next topic is on Robert about HDR.
Yeah, do you hear me? Does it somewhat sound good on your side? Can I have a quick egg that you can hear me, Georges? Hello, hello?
We can hear you. We can hear you.
You can hear me?
Yes, we can hear you.
Okay, cool. So the HDR stuff part is something mostly Sebastian Wick and Jonas Adler have been working on. I'll try to represent that in their set as good as I can. I won't go into detail what HDR is. I hope to have some idea, but maybe one quick note. What's important here is HDR is more than just more colors, but especially means something like you have white that is whiter than what your normal white is. This will be important. Overall, the reason why all this work in HDR takes so long is that in a general desktop environment, things are way more complex than in an embedded space where you might have just one full screen game, one full screen video. We have, generally, we have to mix HDR content with SDR, like legacy classical content, in a seamless manner. And as you know, as I just said, you might have an HDR video where you have super bright light, super bright white, which is so white that if you would make your whole screen that way, you would get totally, your eyes would hurt. And next to it, you have an HDR client, which is also white, but this white is, of course, much less white. And this is all something that the compositor has to get right. And yeah, now with the upcoming release in 47, we have that kind of running. We can now mix HDR and SDR content in our experimental mode. And the Wayland protocols are getting closer to get merged. And there was also a recent Hackfest where we got things closer, and hopefully all of this will drop soon. More likely 48 than 47. Next slide, please. A note here is that on a lot of hardware, enabling the HDR mode can cause increased power usage. That is because you want to have the super white, you need a lot of backlight power if you use a technology which is, for example, not OLED. And so this is heavily hardware dependent, but in general, at least in the beginning, we will have to make it an optional thing. And for now, this is kind of hidden in Looking Glass or debug tool. And soon we'll probably have like options for that, even us in GNOME. Next slide, please.
Nice.
And this is a not really HDR related thing, but it's kind of preparation for that. What happened in the during the last year is that we finally moved from 8-bit components to 10-bit components for the defaults, like back buffer that we draw in Mutter, which means like you will have less, or you might have noticed that you have less banding artifacts in some situations, which is nice, and we need it anyway for HDR. Next slide, please. So we got a lot of awesome work on variable refresh rate. Shortly here again, like for many actions like scrolling and so on, you of course want the highest refresh rate your monitor supports. In other situations, especially for videos, for example here, you watch video with 60 FPS on a monitor with 144 Hertz. This doesn't quite match. It's not a multiple of each other. And therefore, you get not optimal results. So in short, for video, it's often nice to reduce the refresh rate. For games, it's it's even a more complex topic as far as I know. Won't get into that. The decision when exactly to enable that is again a bit hard, and we haven't that fully figured out. So this is still considered an experimental feature because we would like to not have an option, which is our big goal, of course, always. And the kernel IPs are also not quite where we would like them to be. Expect further development. Next slide, please. Video offloading, this is now a topic that I actually worked on and can say something about. YOV or YCRCB support, this is about a pixel format. In short, it's often better to use one of these formats instead of RGB because for the content it often allows us to use less space. This is called subsampling. And normally hardware decoders, for example, or also software decoders could use these pixel formats. But when we put the content on the screen eventually, at some point we have to convert from YOV to RGB. And classically, normally, until very recently, most of your apps did that like themselves and then send the RGB format to a compositor, which then put it on screen. Now you can actually pass on YOV buffers directly to the Wayland compositor, which again might, in some cases, if the stars align, as Matthias Klaassen said yesterday, I think, can then again be passed on to display hardware. And this allows us allows GTK4 video players, for example, or also hopefully soon browsers, etc., to play video much more efficiently. So you get maybe in some cases several hours more battery life. It's also a bit related to the HDR part before, because depending, like if you have an HDR video, you need all the information passed to the compositor to do this conversion properly. So this kind of goes hand in hand and allows us to become a quite good video platform increasingly. Next slide, please. I didn't say that this YUV support landed in 45. And in 46, we built up, had a few improvements on that side, especially that we finally started to use dedicated display hardware to do scaling and cropping options, or to support that. And that means that a client can send us content, and even if it doesn't match the screen exactly, for example, a video again in full screen mode, even if that video has the exact resolution we need for the screen, we can now just scale it in very efficient, or use very efficient hardware to do that. Also cropping. And one optimization, which I'm very happy about, is that we also allow direct scan out, which is like sending the content directly to the display hardware, even if it needs black bars on the side. And for that, in some cases, we need the information from the client that this is a black area. And there's a dedicated protocol, Wayland, which it also has other usages, but especially for that, it's very useful to say, hey, I want to create a black area. And if a client does that, like creates a black area, and on top of that, there is content, like either video or a game or something, which is smaller, we detect that and can use the display hardware again to show the content on a single hardware plane. Because in Mutter, so far, we only support a single hardware plane, apart from the cursor plane. If you don't know the word, doesn't matter. We plan to improve on that even more. And in the future, also support so-called overlay and underlay planes. This is technical details. But in short, with Wayland, we can use display hardware the way it's like, we can use features of display hardware to make things way more efficient. Okay, next slide. Screencasting, very shortly. We had a few performance improvements. We have explicit modifier support now, which is great for several things, and explicit sync, as we said before, is now supported. Next slide.
Yeah, so these are my bits. During the last year, we managed to get the last pieces of the graph rework. This is something that has been happening during the last 3 years or 4. It was a reunification of the mechanisms that allow to redirect input within the shell. And it used to be quite a disaster, like the 5 or 6 different pieces of grabbing mechanisms, different ways to redirect events somewhere else. And now everything is going through a single mechanism in the shell and towards Wayland clients and everything integrates properly in the shell. So yeah, it allows us to deal with input in a quite more consistent way than that we could not afford to do before, so that's nice. In 46, we also got merged the gesture framework from Jonas. And yeah, and hopefully we would like to build on top of that for 47 and to actually include some gestures that use this framework and integrate them in the shell. And it's still under review, but optimistically it should happen. And then there's also some work from coming from STF, from Dorota and Matt, about working on global shortcuts, both for applications, both phase 2 applications and phase 2 accessibility, which is something that was kind of lacking, but well, we now have two implementations even. So it will be sorted out, and it will hopefully land for 47. Next slide, please. So we also earned quite some configuration for input devices. For tablets, there is an improved pressure curve calculation where, well, we used to have in settings, you could get to choose how much pressure should the stylus handle. And it did have too few options. So we've increased that. So it's basically now a continuous slider. So you can get to decide a suitable curve between hundreds instead of 7. There's also pressure range support where besides the pressure curve, that there is in some devices the topmost pressure that you can apply, it could actually physically break the device. So the users would like to narrow that. So or even on the other side, a too soft touch would already produce input even when it shouldn't. So the user can now narrow the edges of this pressure curve. So yeah, they don't have to stuff the tablet to get maximum pressure, or the minimum pressure works as expected. There is also stylus actions, so you can apply key bindings or switching to another display through the stylus buttons. This was previously available for pads, which are the collection of buttons on the side of the tablet, but now you can also do it from the stylus. There is also tablet disambiguation, which is most relevant for professional artist setups. Like imagine you have, there are tablets which are attached to a display, and people even have 2 of them, which are the same identical brand and model. So we can now disambiguate which one is left and which one is right. So we always configure the left one as the left one and the right one as the right one. It's a convenience for really advanced setups. And we also got trackball independent settings, which are separated from mouse settings. So well, people using trackballs and track points, they also get some more granularity. And we also got the ability to provide the XKB model, which might, for people who have keyboards that not have more keys than the PC 105 kind of default. So yeah, next slide, please. And we also got a few Wayland protocol implementations, some on the way, some already landed. We got DRM LIS, which was already covered. We got Linux DRM sync object, which is about synchronization, which was also covered before. We got XDG dialog, which is an extension of the private GTK protocol and made actually proper upstream, and we now use that to declare relations between windows. We got a stable tablet protocol, which was about time since, well, it was done like years ago, and it hasn't changed too substantially, so it made sense to be stable. And we also got a session management implementation, which hopefully will land for 47 and, well, allow applications to store their state in the compositor, like window positions and workspaces and sizes and everything. Next slide. Yeah, well, special mentions. Next.
I can take it over. Yeah, so basically, very briefly, special mentions, honorable mentions, they couldn't fit in they don't deserve, quote unquote, a slide of their own, but basically this is the Bilal's work mentioned. Lots of Cargo cleanups. We removed more than 7,000 lines of code from Cargo in the last cycle. We don't depend on JSON glib anymore. And I think the biggest subject, the biggest topic on a few pull requests was also removing Cairo from the dependencies, the external and internal dependencies of Mutter, which is also pretty difficult, but it's happening. This is I think all of these points have been done by Bilal, so huge thanks to Bilal. And now we're gonna quickly move to, oops.
Does it make sense?
GNOME Shell?
We have 5 minutes to rush through everything plus questions.
It's pictures.
Okay, I try to rush through the remaining slides like the GNOME Shell side. So starting with notifications. That is an ongoing process. It was on the design team's wish list for a long time. And it's finally happening thanks to sovereign tech fund funding. Part of it is already in 46. What is mentioned here are the user visible changes. There was also a lot of refactoring and API changes involved. But what we got was headers on top of every notifications, the ability to expand notifications in the calendar list to get access to actions and the full text. This is also now available in the banners inside the session so that you can actually expand notifications on touch. We hope to implement grouping by app this cycle, but it's still with a question mark because the merge request is still in draft status, and even if it gets submitted for review today, UI freeze is creeping up on us, so we will probably honor the good old tradition of asking for a freeze request. Some of the work involves protocol changes, additions to the notifications portal. This is still under discussion, so it won't make it to 47, but hopefully in 48 applications can make use of those new APIs. This is how a group notification would look when it is expanded. Then I think this is also part of STF.
I'm not sure. I don't, maybe not.
So this is part of digital well-being to configure forced breaks that you have to take to not strain your eyes too much, get enough movement, not sit around for hours. You can configure it to send a gentle notification. You can also configure it to just lock the screen to force a break. Accent colors is something that Alice worked on. Most of the work involved was in libadwaiter, but we also support it in the shell now. It is a controlled way of allowing customizations without a full theme that can significantly break apps. So it should be a lot safer, but still allow users to do some fun customizations. It has been standardized as part of the XDG settings portal. So it should be, at least it is possible for other platforms to support it. There's interest to implement it, support it in elementary and in KDE. Hopefully third-party apps will also support it. There have been a couple of accessibility improvements, nothing major, and probably should skip over those. Some of the screencasting improvements have been on the shell side as well. There's a built-in screen recorder, and it's now possible to use DMA buff if possible, which allows the to pass around buffers between the composite and the recording process without doing unnecessary copies, so it's more efficient. And in the upcoming versions, if available, it's also possible to use like hardware encoding if supported by, like if the drivers are installed and supported. Some special mentions here as well. The on-screen keyboard was improved. That is already in 46. I quickly mention it. The extension state has been improved. Not sure I should explain that. There was also like a slight ambiguity between a user requesting an extension to be enabled and an extension actually being enabled. We now have like two separate states for this to make the distinction where it makes sense. For instance, if the user wants an extension to enable an extension, but it fails and is an error state and not enabled, but still the user would like it. And there we are with questions, and 1 minute left. Thanks, Robert.
On the final slide, it said captive
Does work?
portal.
Okay. I have one question, and it's about the compositor passing through like videos and stuff. Is there also maybe in the future more stuff possible, like rounded corners or other cool things, and not just like maybe black bars at the sides?
I think I'll take that. So, who's talking? Go for it. Okay. So we talked about that at the recent HDR Hackfest in Spain, and there are good arguments for thinking about some Wayland protocol extension which would then maybe allow that. So we can have something like a pip window with a video, which is still hardware offloaded and super efficient. No concrete plans yet. Yeah. But we would like to see it at some point.
We have a question here in Denver. Can you
Hi.
ask?
On the final slide, it mentioned improvements to captive portal handling. Could you just give a few more words about what that means?
The captive portal? You want to talk about it?
Like captive portals are what you have, for instance, on free Wi-Fi's on airports or like at venues like here. That right now we detect like limited network access, and we just pop up the portal login. The changes are that instead we do something similar to Android. We pop up a notification that, do you want to sign into this network? You click the notification, and only then we pop up the login portal. It's not like a huge change, but I think it's worth mentioning. It does have a CVE for some reason, so.
I think we had one more question. We'll take that one and then we can finish. Yeah.
We have a question here in Denver.
At the beginning of the talk, you mentioned Wayland-only builds. Does that mean no X-Wayland, or does that still work?
It can mean both. Like, it's possible to disable support for X11, like running on top of an X11, like an X server. It's also possible to disable like even support for X11 applications. We don't expect that to be like the default anywhere, anytime soon. But it's those are two different things, and both are supported by build options.
Okay, thank you.
Not in random.
Can you shortly repeat the question?
You asked to repeat the question? Is that it?
Oh, Florian, can you shortly repeat the question? It unfortunately didn't arrive here from the screen as stream.
Oh, whether like this Wayland only builds was about disabling Xorg support or also disabling support for X-Wayland.
Okay, thank you. Thank you so much.
All right, we're wrapping up then.
Yeah.
Thank you.
We have one minute.